Hello and welcome to this ATH Productions chemistry video. This is the first video in our metals topic, covering the question, what are metals? In this episode, we look at the difference between the properties of metals and non-metals, as well as looking at choosing metals for particular uses. There are about 117 different elements or pure substances. Almost all of these, around 95 of them, are metals. Elements are arranged in order in the periodic table. The divide between metals and non-metals isn't clear-cut. Some elements in the boundary area have some metal-like properties and some non-metal-like properties. They are known as metalloids. So drawing a line between the two can be debated, but I have drawn it here like stairs to make it easy. Metals are on the left of this line and non-metals appear on the right-hand side of the periodic table. So we know that most elements are metals. We know they are on the left of the periodic table. You will know quite a few metals from your experiences in life. Metals are all around you. But what makes a metal a metal? Well, there are certain properties that we use to classify an element as a metal. There are exceptions to many of these properties, but metal elements show most of these properties. Metals are shiny. The scientific word for this is lustrous. Non-metals tend to be dull. We do have to clarify that as metals often react with air and get covered in dull oxides, so it is best to say that metals are shiny or lustrous when freshly cut or polished. Metals have high densities. They are heavy for their volume. There are exceptions. For example, sodium and potassium have low densities. In fact, they can float on water. Metals have high melting and boiling points. Because of this, metals are all solids at room temperature. Mercury is the exception. It is in fact a liquid at room temperature. Gallium melts at just under 30 degrees Celsius, so it will melt in your hand. But almost all metals have high melting and boiling points, whereas non-metals have low melting and boiling points. Many non-metal elements are gases at room temperature. Metals make a metallic ringing sound when you hit them. They are sonorous. That is why we use metals for cymbals, bells, and gongs. Metals are electrical conductors, whereas non-metals are electrical insulators. All metals let electricity flow through them easily. Non-metals do not. Metals are also thermal conductors, letting heat travel through them easily, whereas non-metals are thermal insulators. Metals are ductile, malleable and strong, whereas non-metals are brittle. Ductile means that if we stretch the metal, it will be drawn out into a wire. If we try that with a non-metal, it will break. Malleable means that you can hammer the metal into another shape. Blacksmiths used to hammer iron on an anvil into shapes. For example, when making horseshoes. If you hit a non-metal, it will shatter as it is brittle. Metals are strong. That is one of the things that makes them very useful. There are a few exceptions. For example, sodium and potassium can be squashed between your fingers and easily cut with a knife. Another property that is often associated with metals is that they are magnetic. I don't like this one. The reason for this is that of the 95 elemental metals, only 3 are magnetic. Iron, cobalt and nickel, which sit together in the periodic table. All of these properties, we have discussed and noted, are physical properties. Physical means that the property is about how it looks and feels, characteristics of the material that are not to do with its chemical behavior. There is one chemical property of metals that we need to know. Metals, when heated with oxygen, produce oxides that are alkaline. Non-metals produce acidic oxides. Let's have a look at this in the lab. Here we have a small beaker of pure water. Some universal indicator is being added. The universal indicator is turning green, demonstrating that the water is neutral, pH 7. We are now blowing into the water through a straw. Exhaled air contains carbon dioxide. Carbon is a non-metal and carbon dioxide is its oxide. You can see that the universal indicator is changing color to yellow, showing that the pH is lowering towards the acid side of the pH scale. This simple experiment demonstrates that the oxide of a nonmetal is acidic. This is a chemical property of nonmetals. Here we have reset up the water and universal indicator. Again, it is neutral at pH 7. We have here a piece of magnesium, a metal. When we light it on fire, it produces magnesium oxide with a bright white flame in a dramatic, exothermic reaction. When we drop the magnesium oxide into the water and stir it, you can see that the universal indicator is changing blue, showing the pH rising into the alkali side of the pH scale. This demonstrates that the oxide of a metal is alkaline. This is a chemical property of metals. In summary, metal oxides are alkaline, non-metal oxides are acidic. I have summarized the properties we have looked at in this table. All but the last properties in the table are physical properties. That is, they are not about the chemical behavior of the elements, but about their look and feel. We see here that metals are lustrous or shiny, whereas non-metals are dull. Metals have high densities, non-metals have low densities. Metals have high melting and boiling points, non-metals have low ones. Metals are sonorous, they make a metallic ringing sound, whereas non-metals do not. Metals are conductors of both electricity and heat, non-metals are insulators. Metals are strong, malleable and ductile, non-metals are brittle. The last property on the list is the one chemical property we need to know, that is that metals make alkaline oxides. Non-metals produce acidic oxides. When we need to use a metal for making an object, we think about these properties and choose the metal that is best suited for the job. Let us look at some examples of choosing metals for particular jobs. Here we can see a cooking pot. This one is made from the metal element, copper. Copper has been chosen as it is a very good thermal conductor, meaning that the heat from the stove can pass through the copper easily into the soup. Copper is also malleable, so it could be shaped into the pot shape. It is also chosen as it has a high melting point, so won't melt in the hot flame. Notice that the plastic handle and wooden stirring spoon are made from non-metals. This is because non-metals are insulators to stop the chef being burnt. Copper is also used in electrical wiring. This is because it is a very good electrical conductor. Copper is also ductile, so can be drawn out into the wires. Copper is also strong, so will not break during the wire's years of use. When choosing a metal to use to make a safe to keep your valuables in, a very strong and dense metal is the best. This safe is made from iron. Iron is not only strong but when heated is malleable, so the safe shape could be made. When making an aircraft, it needs to be strong, but the major consideration is not making it too heavy. Aluminium is used as it has a low density for a metal. That combination of strength and low density make it perfect for the job. When you are making jewelry, a metal that is easily shaped is important. Gold is quite soft, therefore it is very malleable and ductile, making it perfect for jewelers to work with. Gold is also very lustrous, and as it is not very reactive, it stays shiny, ideal for making a crown. When making a bell, again the material needs to be strong and malleable, but of course the key property to think about is how sonorous it is. Sometimes you are unable to find a metal that has the perfect set of properties to complete the task you need it to do. In this case, we can mix metals together to get the properties we need. A mixture of metals is called an alloy. Here are some examples of some common alloys. Iron is widely used for cars, bridges, and construction, but it isn't quite as strong as it needs to be. Iron is therefore mixed with a little carbon to make the alloy, steel, a much stronger metal. Iron and steel rust, and for some items such as knives and forks, rusting would be a problem. Iron is then mixed with chromium to make the alloy stainless steel, which doesn't rust and stays shiny or lustrous. Aluminium is used for aircraft due to its low density, but it isn't strong enough. So aluminium is mixed with some magnesium to strengthen it, making the alloy duralumin, dur meaning hard. Trumpets and saxophones are made from brass, a mixture of copper and zinc. The alloy brass is easily machined and looks a lovely lustrous golden color. A similar, but more ancient alloy is bronze, a mixture of copper and tin. Again, it is a nice golden brown color and is stronger than pure copper. It is used for metal statues. If we have a substance and we want to check if it is a metal or a non-metal, then we need to investigate. We need to look at its properties and see if it fits with metal or non-metal properties. The easiest and best property to investigate is electrical conductivity. This is because you do not need to damage the substance or do any complicated experiments. The way we can check if it is a metal or not is by simply adding it into an electrical circuit with a battery and a light bulb. If the bulb stays off, then the material is a non-metal as it is an insulator. If the light bulb lights up, then the material is a conductor and therefore a metal. Quick and easy. There is one exception you need to know about. The element carbon is a non-metal, just to the right of our dividing line on the periodic table. Carbon can be found in a variety of forms including diamond and graphite. When in the form of graphite, as found in your drawing pencil, it in fact conducts electricity, so we need to be aware of that. In this lesson, our first in our metals series, we have learned the following. Metals are on the left of the periodic table and most elements are metals. We have found that metals have different physical properties to non-metals. Metals are lustrous, sonorous, malleable, ductile, strong, dense, and have high melting and boiling points. Metals also have the chemical property of having alkaline oxides. We know that we look at properties when choosing a metal to do a particular job, and that if we need to, we can mix metals to form an alloy. The easiest way to test if a material is a metal or not is to test if it conducts electricity. I hope you have enjoyed this lesson. Bye for now.